All right, here we have another problem that we're supposed to solve this polynomial equation. And again, if we're just solving for p, that would be great, but we have p cubed, p squared, and a p. So we can't just isolate the variable in this case. It's almost like we have three different variables. So we're going to have to use our zero product property. But the zero product property says we have to have factors equal to 0. Well, it's equal to 0, but we don't have factors here. So we're going to have to correct that. We're going to have to factor this left-hand side first. So because we have 4 terms, we're going to factor by grouping. So looking at the first 2 terms, these have a p squared in common. So when we factor out the p squared, we have 2p plus 5. And when we factor out the second 2, again, we want 2p plus 5. We want that same binomial. So what times 2p would give us negative 8p? That would be a negative 4. And let's check it. Negative 4 times a positive 5 is a negative 20. So that was the correct common factor to pull out. Now we have 2p plus 5 in common for both of those terms. So when I factor that out, we're left with a p squared and a minus 4. P squared minus 4 equals 0. Now we do have factors equal to 0, but there is one problem here. This is not fully factored. This p squared minus 4 is a difference of 2 squares. It really needs to be fully factored in order to use the property properly. So 2p plus 5, we cannot factor that down any further, but p squared minus 4, since it is a difference of 2 squares, will factor into p plus 2 times p minus 2 equals 0. Now, just because we have 3 factors this time rather than 2 factors, that doesn't really make any difference. The rule says when you've got factors equal to 0, then one of them must be 0. So it doesn't matter whether we're multiplying 2 things together or 3 things together or 10 things together. In order to get 0 as an answer, one or all of those have to be 0. Or I should say one or more of those. So we can still use that same idea. Either this has to be 0, or this has to be 0, or this has to be 0. So we're going to separate this out now into 3 separate equations. Either 2p plus 5 is 0, or p plus 2 is 0, or p minus 2 is 0. So if we solve the first one, we'd have to subtract 5 from both sides to get 2p equals negative 5. And then dividing both sides by 2, we would get p equals negative 5 halves. There's one answer. For the second one, we would have to subtract 2 from both sides to get p equals negative 2. There's our second answer. Now for our third one, we have to add 2 to both sides to get p equals positive 2. So we have 3 answers for this problem. Now, if you've been following along and doing these videos in order, I hope that you're kind of starting to recognize a little bit of a pattern here. When we very first started working problems and we were doing things like, I think I used the example earlier of the 3x plus 5 equals 14, we ended up with one answer. When we have done problems like x squared minus 5x plus 6 equals 0, we've ended up with 2 answers. And now we've done a cubed problem and we ended up with 3 answers. Isn't that interesting? That's a pattern that is absolutely worth noting for later on.